Okay, so a very fundamental skill that you need in this class is naming compounds and then being able to write the formula, because without those things you can't get the equation correct, you can't get the stoichiometry correct, and there's very little that you can actually get correct if you cannot get the formula correct. So, very important skill. So the first thing, when you have a compound, you have to decide if it's ionic or covalent. That's the very first thing you have to do. So if you have an ionic compound, ionic compounds are composed of metals and nonmetals. So you have to look and determine, is this a metal and a nonmetal? So if you look at your periodic table, everything to the left of this little staircase right here, everything to the left is considered a metal, okay, which is most of the elements right here. Hydrogen, of course, is not. Now, everything to the right would be considered a nonmetal. So we actually have very few nonmetals. So if you have an ionic compound, you're going to see a metal, and then you're also going to see a nonmetal. So if they're very far apart on the periodic table, it's probably an ionic compound. Now, if you have a covalent compound, alright, so if you have a covalent compound, you're going to have two or more nonmetals. So everything should be on the far right hand of the periodic table, may include hydrogen too. But it's all nonmetals. Okay, the naming systems are different and also the way you write the compounds are different. So you have to be able to recognize what type of formula it is. So if I have KO, I'm looking at this, well, this would be potassium right here, and this is oxygen. If I look it up on the periodic table, K is actually a metal, oxygen is a nonmetal, this would be an ionic compound. Alright, so let's look at something else. Okay, so charges. Okay, when you're looking at ionic compounds, you have a nonmetal and a metal. Well, metals like to give up electrons, so these materials will give up electrons to become positively charged, and then nonmetals will gain those electrons to become negatively charged. So when you have an ionic compound, really what you have is a metal that has lost electrons and has become positive, and a nonmetal that has gained those electrons and become negative, and then because of that they are attracted to each other. So you have to know the most common charges. You have to know it. So if you look at the periodic table, there's a very easy way to tell what most of the charges are. So if you look at the groups, and you should have a periodic table out and be recording this if you don't have a periodic table out. Okay, so group 1 will lose 1 electron to become +1 when it becomes an ion. Group 2 will become +2 when those become ions. Now this little group down here, the transition metals, a lot of these can have more than one charge. They just get really funky. So we don't really have a specific way to know those. But if you look on your reference sheet, you'll see that I do list the most common charges for some of these. Alright, so group 3, or 13, has a charge of +3. Group 4 typically do not make ions. Some of them do though. So we say no charge, but tin and lead can actually have more than one charge. They can have a +2 or a +4. So those are the exception in that group. Now, when you get to group 15 or 5A, those are mostly nonmetals, so they start to gain electrons. So they are going to be negatively charged. So this would have a -3 charge. Group 16 or group 6A would have a -2 charge. And then group 17 or 7A will have a -1 charge. 18 or 8A, those are the noble gases. They don't typically make ions, so we don't worry about that. So you need to know these most common charges. So +1, +2, +3 for group 3, +4, or I'm sorry, no charge. No charge for group 4 except for tin or lead. Those can have +2 or +4. Group 5A would be -3, group 6A -2, and then group 7A is -1. Now, some other ones that you just have to know because they're common, they're used a lot. Zinc is +2 when it becomes an ion. It doesn't have more than one charge, you just need to know that. And then silver is +1. You just need to know these charges. They're always that charge. You need to know those charges. All right, so now that you have that information, let's look at some naming and writing the formulas. All right, so when you have an ionic compound that's binary, that means it only has 2 elements. So it's just a metal and a non-metal. Okay, binary, bi means 2, so it has 2 elements in it. When you have an ionic compound, you should see a metal and a non-metal. When you name it, the name of the metal will always stay the same. So calcium would stay calcium, magnesium would stay magnesium. If it is a transition metal, or basically if it's a metal that has more than one charge, you have to include the charge in the name. You have to indicate whether it's copper 1 or copper 2. You have to do that, otherwise the person who gets it won't be able to write the formula. The nonmetal, the ending is going to change to IDE. Now, when you're writing the formula, the charges have to cancel to equal 0. You can use something called the Crisscross Method, but you need to make sure the charges at the end equal 0. The cation, which is the metal, or the positive ion, is always first, always and forever. All right, so let's go ahead. Let's name some of these compounds. All right, so first thing I'm going to do, I'm going to determine whether it is an ionic compound or not. So Na and Cl. So if I look up Na is a metal, chlorine is a nonmetal. So the metal name stays the same, so it's just sodium as the first part. Sodium is not an element that has more than one charge, so it's not a transition metal, it's not tin or lead, so I don't need to worry about the charge, so it's just sodium. It's always a +1, which is why I don't need to write it. Now the nonmetal, which is chlorine, will become chloride. So that I and E becomes IDE at the end. So it's just sodium chloride. All right, so now if I look this one up, Sr is strontium, which is a metal, and O is oxygen, which is a non-metal. And you should have your periodic table out and be looking at this as I'm doing this. So the metal, nothing changes, it's just strontium. All right, strontium is in group 1. It is not one of the transition metals. It doesn't have more than one charge, so no need to include that. And oxygen becomes oxide. All right, so let's look at the next one. So we have Ca, which is calcium, which is on the left of the periodic table. It's a metal, so calcium just stays calcium. It is not a transition metal. It is not a metal that has more than one charge, so I just leave it alone. I don't worry about the charge. And then nitrogen becomes nitride. All right, let's look at the next one. We have K2O. So K is potassium, which is a metal. So the metal name does not change, it's just potassium. It is not a transition metal. It doesn't have more than one charge, so I just leave it alone. And then oxygen becomes oxide. All right, so now we look at the next one. Cu is a metal, oxygen is a nonmetal, so Cu is copper. But copper can either be +1 or +2. It's a transition metal, so it's got more than one charge. It's one of the metals that can have more than one charge. So we need to include that in the name. So what we have to do is we have to look at the charges. So I want you to look up oxygen on the periodic table. If you do that, you'll see that it has a -2 charge. Now the thing about ionic compounds is the charge needs to equal 0 overall. So overall, this whole thing equals 0. So if I have one copper atom, here, and one oxygen atom, and you can tell because there's no subscript, no small number here, so there's just one atom of each. If I know that oxygen is a -2 charge, and there's only one of those, what does the charge of one copper atom equal if the whole thing is 0? Well, in order for this to equal 0, I have to have a +2. So that means that this copper atom has a charge of +2. So it's going to be copper, Roman numeral 2, oxide. Okay, so let's look at the next one. Okay, so Cu2O. So this is clearly different than the last one because this one has 2 copper atoms instead of just one. Same elements, but different ratio. Oops. All right, so again, it's just going to be copper. All right, so it's going to be copper. Now I need to look at the charges because copper, it's either +1 or +2 here. So I have Cu2O. I have one oxygen atom and 2 coppers. Well, I know that oxygen has a charge of -2. There's only one of those. I know that the overall charge has to be 0. Copper here has some charge. I don't know what it is, but there's 2 atoms here. So basically, I have 2 times some charge plus -2 times 1, so -2, and that's equal to 0 overall. Well, if I do the math here, 2x is equal to 2. Well, then that means that x has to be 1. The charge of the copper here is 1. So really the only difficult part of naming ionic compounds is really just if you need to figure out the charge or not. So really just remember that if you have an ionic compound, everything overall is 0. All right, so let's look at writing the formula. Okay, so writing the formula, you need to look at the charges. The charges have to be 0 overall, and there's a little method you could use to kind of like simplify it. And basically, when you look at the periodic table, you're going to find the charge of each thing. So first of all, you know that these are going to be ionic, so you should have metals, nonmetals, metals, nonmetals, metals, nonmetals. So Right here, magnesium is in group 2, and group 2 has a +2 charge. Nitrogen is in group 3, which has a -3 charge. So hopefully you wrote those all down so you can just refer to your notes for that and then, memorize that. Okay, so magnesium nitrate. So we're going to do something called the Crisscross Method, and then I'm going to show you why this works. Okay, so magnesium, always write down the cation first. So the metal always comes first. Always, always, always. So the metal has a +2 charge here, and nitride is nitrogen that has a -3 charge. And you get that from the periodic table. All right, so what you're going to do is just pull the metal down, pull the nonmetal down, and then crisscross. So the 2 will come down here and be a little 2 by the N, and then the 3 will come down here, be a little 3 by the Mg. So it's just Mg3N2. Okay, and then what you do is you look, okay, if these numbers that you pull down can reduce, you can reduce them. The numbers that you pull down. If they can't reduce, leave it alone. But let me show you why this works. Remember, everything here has to be 0. Well, magnesium has a +2 charge. There are 3 of those. So 3 times a +2 would give me a +6. Well, nitrogen has a -3 charge. There are 2 of those. Okay, so that means you're going to have a -6 charge here. So a +6 plus a -6 would give me 0 if you add them together. So remember, overall it should be 0. All right, so let's look at barium bromide. All right, so barium is right here. It's in group 2. It's +2 charge. And bromide is in group 7A or 17, which has a -1 charge. All right, so barium has a +2 charge. Bromide has a -1 charge. All right, so crisscross. Bring the metal down. Bring the nonmetal down. The 2 will come down here, be a little 2. The 1 will come down here, but it's improper to actually write the 1. So you don't need to. So it's just Ba, Br2. 1 and 2 can't reduce, leave it alone. Now, let me just show you one more time why it works. Barium's a +2. There's only 1 of those. Bromine is a -1, and there are 2 of those. So -1 times 2 would give me -2, and then I have a +2 right here. So +2 minus 2, 0, it's good. All right, so let's look at the next one, aluminum phosphide. Okay, so aluminum is in group 3A. Okay, group 3A, so it has a charge of +3. And phosphide has a charge of -3. All right, so aluminum has a charge of +3, phosphide, -3. All right, so I can look right away. I have a +3 and a -3. That cancels. So I only need 1 of each. So it's just AlP. Now, you can just reason your way through it, and that is the formula. Or if you want to, you can crisscross. And what you would do is you would see they would reduce. So bring the metal down, bring the nonmetal. Little 3 comes down here. 3 comes down here. I have a 3 and a 3 that I pulled down. I can reduce that to 1 and 1. So my formula should just be AlP. And now if you have Al3P3, that's very, very improper. And AP, the College Board would definitely mark you off for that. So you need to make sure that if it cancels or if you can reduce, you need to reduce. Okay, so the next one, and I will say this, you should go ahead, pause it, see if you can do the rest on your own. I'm going to go ahead and continue though. Okay, so lithium chloride. Lithium is in group 1, it's +1. Chloride is a -1, well, +1, -1. They cancel. It's just Al or LiCl, and that's it. All right, let's look at the next one. 10,4 bromide. Well, all right, so 10,4, there's a number here. That is because 10 can have more than one charge, so they had to tell you what the charge of 10 was. And 10's symbol is actually SN, so it has a charge of 4. This tells you that the charge is 4 here. All right, so Br is -1. So let's bring SN down, bring the metal down, bring the non-metal. 4 comes down here, 1 comes down there, but you don't write that, so this is the formula. SnBr4. Can't reduce that, so we move on. All right, so the next one, 10,4 oxide. All right, so 10 has a charge of 4. I told you. Oxygen has a charge of -2. All right, so bring the metal down, bring the oxygen down. Little 4 comes down here, little 2 comes down here. Well, I have a 2 and a 4. That can reduce. So I can divide both of those by 2, so it's SnO. 4 divided by 2 would be 2. I only need 2 oxygen atoms to balance out the 1, or the +4 charge, rather, and 1 10 atom. So if you can reduce, you need to, because this is not appropriate. Okay? All right, and we're going to be doing a lot of practice problems with this. One of those things, just practice, practice, practice.